Hello there. So today we'll be looking at generalized linear models, how to put certain distributions into exponential family form. This is usually simple, but it takes a lot of practice. So today we'll start off with a normal distribution into an exponential family form. And okay, so let's start. So the exponential family is written in the form theta y minus b theta over a phi plus c, which has the components y and phi. And we shall be looking at our goals in this case, which is first of all to convert the the normal distribution into the exponential family. Our second goal would be to find the mean, which is the first derivative of b of theta. And then we would find the canonical link function, which is the inverse function of b prime. And then find the variance function, which is the second derivative. And then we find the variance, which is just a of phi multiplied by the second derivative. So it's pretty simple. If you understand, you just have to bam, 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 do it, okay? So we will begin because I know you guys are probably studying for exams. So the normal distribution PDF, some professors will give it to you, other professors won't. I like to give my students the PDF because I don't think it's something you have to cram. So it's a function of mu and sigma squared, and it's usually equal to 1 divided by the square root of 2 pi sigma squared. I unfortunately forgot the square root, but I added it later. And exponential into negative into bracket x minus mu squared over 2 sigma squared. And we can simply write this, take the square root up so it's easier to write. And we get 2 pi sigma squared to power negative a half exponential what's in the bracket. That is a really long function to state, so just look at what I'm doing, and that's the PDF. So the first step in every situation is to take the logs of both sides. So on the left side we get log of f, and on the right side we bring the negative a half down, and we get is equals to negative a half times log 2 pi sigma squared. And then we remove the exponential because log times exponential is just nothing, right? So minus x squared minus mu divided by 2 sigma squared, right? As you can see. So the second step is to take the exponential. So the exponential removes the log on the left hand side and puts an exponential function on the right hand side. So f is equals to exponential put into brackets negative a half log 2 pi sigma squared minus x minus mu into brackets squared divided by 2 sigma squared, right? So we have that exponential function on the right hand side. And what we're trying to do is to try and make it seem like the exponential function. So how do we do that? I would invite you to just take a minute, look at the function. How do we make it look like an exponential function? The first step is to think that the log function would be the constant, and the x minus mu function would kind of look like the theta y minus b theta over a phi. So let's move and switch sides and kind of try and simplify it and expand it. So that's what I've done. I've moved it to the left side, and I'm going to try and simplify it. So I'm going to open the bracket. I will multiply in, and what do we get? We get negative x squared plus 2x mu minus mu squared divided by 2 sigma squared. I hope you can see how I did that. I just expanded whatever was in the brackets. And I left the constant, which is the negative a half log 2 pi sigma squared, as it is, right? So I'm trying to make it seem like the exponential function. So how do I do that? I will kind of move things around, and I'll bring 2x mu to the front minus mu squared. I'm putting like terms together, And I will separate the function. So I'll put the fast divided by 2 sigma squared minus x squared divided by 2 sigma squared minus a half log 2 pi sigma squared. So that's kind of starting to look like the exponential function. If you really look at it, I'm inviting you to take a few seconds, pause the video, kind of try and figure out what I would put as theta y, b theta, and a of phi. Okay? So let's continue. I want to kind of simplify it because this 2 is just really getting in my way. And I will divide everything by 2. So what I get is x mu minus a half mu squared divided by, I divided by 2, so it's just sigma squared, minus x squared over 2 sigma squared minus a half log 2 pi sigma squared. Okay, it's kind of starting to look like the exponential family function. So let's continue. Okay, do you see that resemblance? Okay, we're getting super close. So in this case, y is x, if you really think about it. So theta y is equals to x mu, right? Do you see that? But in this case, y is equals to x. Because I could easily have written the PDF in the form of y instead of x. So that's just semantics. It really doesn't matter, right? And we get our canonical link function, which is our identity function, which is theta is equals to mu. We get a of y is equal to sigma squared. And we get b of theta is equals to a half mu squared. Because theta is equals to mu. I hope you can see this. So b of theta is equals to a half theta squared. I hope this makes sense. Just look at it closely if you're not getting what's happening. And we get our constant function, which is in the form of y and theta, y and phi, as negative a half log 2 pi squared minus x squared over 2 sigma squared. So if you're writing this in an exam, it would be good for you to change the x's to y's. And since we found that a of phi is equals to sigma squared, you can easily rewrite this. So I'm just going to make that clear in a second. So negative a half log 2 pi sigma squared minus x squared over 2 sigma squared, which is my constant function. And I could rewrite this where a of phi is equal to sigma squared and y is equals to x. Just keep that in mind. So pretty much now we are done. So it's just trying to bring out everything clearly. So what is our mean? Our mean is the fast derivative of b prime theta, which we got up there as a half. Okay, so we got b theta as a half theta squared. So our fast derivative is just theta. I hope you know how to do that. You just bring the 2 down, you minus 1, so it's theta to power 1. And yeah, so it just ends up being theta. Our next goal is to find the variance. So the variance is the double prime of b of theta. Okay, so if we got b of theta as a half theta squared, we got the mean, which is b prime theta as theta, then the double prime will be 1. And then we will try and get the variance function. So the variance function is basically double prime, which is what we got earlier. So that is 1. And now we're trying to get the variance. So the variance is a multiplication. It's a product of a of phi times the double prime of b of theta. So the double prime of b of theta is 1. A of phi we got earlier as sigma squared. And therefore it's sigma squared. So we have the mean, we have the variance function, we have the canonical link function, and we have the variance, right?